I'm Hunter Hughes. I'm a master's student at the University of Maryland's Center for Environmental Sciences Chesapeake Biological Lab. And I work with Dr. Hallie Kilborn and Dr. Johan Schiff, where we mostly study how the chemistry of a coral skeleton can be used to understand Earth's climate history. I had visited the Chesapeake Biological Lab and was introduced to Dr. Hallie Kilborn's research, where she used coral skeletons to actually understand past ocean temperatures and salinity, and it just seemed like a perfect fit for me. The climate is changing faster than we've ever seen it before. We have to have some idea of how the climate has operated in the past. Corals are analogous to trees in a lot of ways. They produce seasonal growth bands, and as the chemistry of the seawater around them changes, the coral skeleton will take up different elements to reflect those changes. So I traveled to the Florida Keys, the US Virgin Islands, and the British Virgin Islands to visit field sites that we have located on different coral reef environments. My advisors and I collect seawater samples. We scuba dive to manage experiments that we have set up on the seafloor, and we tend to a group of coral nubbins, or baby corals. The amount of strontium in a coral skeleton relative to calcium has this really nice dependence on temperature, especially in the temperature ranges that corals grow in. So measuring those changes in the coral skeleton help us understand how temperature has changed in the tropical oceans over time. And we want to understand how those coral skeletons changed even better, so we need to understand how the seawater chemistry changes as well. So once we get our seawater samples, we take them back here to the lab and analyze them using an inductively coupled plasma optical emission spectrometer. It tells us how the chemistry of the seawater is changing, and then we can hypothesize how those changes are affecting our corals out in the field. So ultimately, our hope is that our research will help better inform climate prediction models. Most climate prediction models are only using the last 100 years to predict what the next 100 years are going to be like. And with a coral skeleton, you can go back hundreds or thousands of years and understand what climate was like back then. If we gain information on how they've changed over time, we can use that information to better inform climate models that seek to predict future climate.